Write Anywhere File Layout, or WAFL, is the proprietary file system used by ONTAP-based systems. ONTAP software is used to manage the storage systems and data stored on the storage systems. WAFL controls how data is read and written. ONTAP software manages the system hardware and the data on the drives. File systems handle the task of writing and reading data to drives and maintaining a record of where the files reside on the drives. Windows PCs often use the NT file system or NTFS. ONTAP-based storage systems use a proprietary file system developed and patented by NetApp called the Write Anywhere File Layout, or WAFL for short. Most file systems prior to WAFL spent a significant amount of time moving the read and write heads of a disk drive back and forth in order to write data in one location and the metadata about the data blocks to another location. WAFL writes the data and metadata together. This reduced the movement of the drive heads and therefore latency. Imagine a warehouse for a large online retailer. The warehouse stores thousands of products which are listed in a database. The database also stores information about which row and shelf each product is located at, so the products can be easily found before shipping to a customer. A file system is like a warehouse that organizes blocks of data on drives into files. Files are like the products in the warehouse. In order to spread the files across multiple drives and achieve higher performance, WAFL stores files in user-created logical containers. The logical containers, called a FlexVol volume, represent the file system. The location information for the files is referred to as metadata. The WAFL file system stores metadata in inodes. The term inode refers to index nodes. Inodes are pointers to the blocks on disk that hold the actual data. Every file has an inode, and each volume has a hidden inode file, which is a collection of the inodes in the volume. Each storage system maintains its own file system. When storage systems are joined together into pairs, and pairs are joined into clusters, the storage systems work together to distribute the workload. Data that requires low latency may be segregated to storage systems with SSDs, and less critical data may be written to systems with slower hard drives. In this diagram, a client in the engineering department requires low latency and is directly connected to the storage system on the left with fast drives. When a write request is sent from the client, the storage system receives the request through a network interface card, NIC, or a host bus adapter, HBA. In this case, the write is to a volume that is on the node and therefore has direct access. This is a direct write. The write is simultaneously processed into system memory, logged in non-volatile memory called NVRAM, and mirrored to the NVRAM of the partner node of the HA pair. After the write has been safely logged, the write is acknowledged to the client. The write is sent to storage at the next consistency point, CP. In this diagram, a client in the QA department wants to save a report in the engineering department's volume. The QA client is connected to the storage system on the left. The write request is sent from the client to the engineering volume on the left storage system. The write request is processed by the node to which the client is connected. The write is redirected through the cluster interconnect to the node that owns the volume. The write is simultaneously processed into system memory, logged in NVRAM, and mirrored to the NVRAM of the partner node of the HA pair. After the write has been safely logged, the write is acknowledged to the client. The write is sent to storage at the next CP. Because the write request first goes through another storage system, the write request accesses the volume indirectly. When a client requests to read a file, the read request can be handled in three ways: a direct cache read, a direct disk read, or an indirect read. When a read request is sent from the client, the storage system receives the request through a NIC or an HBA. In this case, the read is from a volume that is on the node and therefore has direct access. The system first checks to see whether the data is still in system memory, which is called read cache. If the data is still in cache, the system serves the data to the client. If the data is not in cache, the system retrieves the data from the drives and copies the data into system memory. After the data is cached, the system serves the data to the client. If another client requests the same data, the read request will be handled as a direct cache read. If a read request is sent from the client to a volume that is on a different node, the read request accesses the volume indirectly. The read is processed by the node to which the volume is connected. The read is redirected through the cluster interconnect to the node that owns the volume. As with the direct read, the system that owns the volume checks system memory first. If the data is in cache, the system serves the data to the client. Otherwise, the system needs to retrieve the data from disk first. ONTAP is NetApp's enterprise-class data management software. ONTAP software integrates with WAFL to manage data and files and relies on a Linux-based operating system to manage the storage hardware. In addition to the version number, each ONTAP software release is also assigned to one of 3 release categories: Release Candidate, General Availability, and Patch. Generally, ONTAP-based systems are shipped with a general availability release of ONTAP and should not be upgraded. Newly released AFF and FAS models may ship with a release candidate version of ONTAP software. When the ONTAP version on the storage system has gone GA in the interim, the storage system should be upgraded. The customer may also have certified a specific version of ONTAP software for use in their environment on their other storage systems. This may be a patch release due to issues they have already experienced. NetApp discourages the use of P-releases except when instructed by support to install it. P-releases are often specific to a particular FAS model, drive or drive shelf model, or end-user application, which may not be applicable to the new system. WAFL is a proprietary file system designed to provide better performance than competing file systems. ONTAP is the software that works with WAFL in order to provide the best storage systems in the industry. ONTAP software is released in stages known as Release Candidate and General Availability. Later releases incorporating bug fixes are known as patch releases.